Today's video is about the discovery of a stellar mass black hole. So before talking about that, let's first understand the types of black holes that exist in our universe. Black holes are points in space that are so dense they create deep gravity sinks. Beyond a certain region, not even light can escape the powerful tug of a black hole's gravity, and anything that ventures too close, be it a star, planet or spacecraft, will be stretched and compressed like a putty in a theoretical process aptly known as spaghettification. There are four types of black holes: stellar, intermediate, supermassive and miniature. The most commonly known way a black hole forms is by stellar death. As stars reach the ends of their lives, most will inflate, lose mass and then cool to form white dwarfs. But the largest of these fiery bodies, those at least 10 to 20 times as massive as our own Sun, are destined to become either super dense neutron star or so-called stellar mass black holes. An intermediate mass black hole is a class of black hole with mass in the range of 100 to 100,000 solar masses, significantly more than stellar mass black hole, but less than supermassive black holes. Supermassive black holes are classically defined as black holes with a mass between 0.1 million and 10 billion times that of our Sun. Micro black holes, also called miniature black holes or quantum mechanical black holes, are hypothetically tiny black holes for which quantum mechanical effects play an important role and are less massive than our Sun. The concept that black holes may exist that are smaller than stellar mass was introduced in 1971 by Stephen Hawking. So let's talk about the latest discovery of a stellar mass black hole. A team of international experts renowned for debunking several black hole discoveries have found a stellar mass black hole in the Large Magellanic Cloud, a neighbor galaxy to our own. The study leader Tomer Shenar said that for the first time their team got to report a black hole discovery instead of rejecting one. Moreover, they found that the star that gave rise to the black hole vanished without any sign of powerful explosion. The discovery was made thanks to 6 years of observation obtained with the European Southern Observatory's very large telescope. We identified a needle in a haystack, says Shenar, who started the study at KU Leuven in Belgium and is now a Marie Curie Fellow at Amsterdam University, the Netherlands. Though other similar black hole candidates have been proposed, the team claims this is the first dormant stellar mass black hole to be unambiguously detected outside our galaxy. Stellar mass black holes are formed when massive stars reach the end of their lives and collapse under their own gravity. In a binary, a system of two stars revolving around each other, this process leaves behind a black hole in orbit with a luminous companion star. The black hole is dormant if it does not emit high level of X-ray radiation, which is how such black holes are typically detected. It is incredible that we hardly know of any dormant black holes, given how common astronomers believe them to be, explains co-author Pablo Merchant of KU Leuven. The newly found black hole is at least 9 times the mass of our Sun and orbits a hot blue star weighing 25 times the Sun's mass. Dormant black holes are particularly hard to spot since they do not interact much with their surrounding. For more than 2 years now, we have been looking for such black hole binary systems, says co-author Julia Bodensteiner, a research fellow at ESO in Germany. To find VFTS 243, the collaboration searched nearly 1,000 massive stars in Tarantula Nebula region of the Large Magellanic Cloud, looking for the ones that could have black holes as companions. Identifying these companions as black holes is extremely difficult as so many alternative possibilities exist. Shenar said that as a researcher who had debunked potential black holes in recent years, he was extremely skeptical regarding this discovery. The skepticism was shared by co-author Karim El-Badri of the Center of Astrophysics, Howard and Smithsonian in the USA, whom Shenar calls the black hole destroyer. El-Badri explains, "When Tomer asked me to double-check his findings, I had my doubts, but I could not find a plausible explanation for the data that did not involve a black hole." The discovery also allows the team a unique view into the process that accompany the formation of black holes. Astronomers believe that a stellar mass black hole forms as the core of a dying massive star collapse, but it remains uncertain whether or not this is accompanied by a powerful supernova explosion. The star that formed the black hole in VFTS 243 appears to have collapsed entirely with no sign of a previous explosion. Evidence for this direct collapse scenario has been emerging recently, but the study arguably provides one of the most direct indications. This has enormous implications for the origin of black hole mergers in the cosmos. The black hole in VFTS 243 was found using 6 years of observation of the Tarantula Nebula by the Fiber Large Array Multi-Element Spectrograph or FLAMES instrument in ESO. Despite the nickname Blackhole Police, the team actively encourages scrutiny and hopes that their work published in Nature Astronomy will enable the discovery of other stellar mass black holes orbiting massive stars, thousands of which are predicted to exist in Milky Way and in the Magellanic Cloud. Thank you for watching and subscribe to my channel for more interesting videos. You can check out my Instagram page for amazing facts and information on astronomy. Have a good day.